Dear students, welcome to the knowledge series on page fault. See, a page fault occurs when a programs that need to access the memory is not able to store the certain content from the main memory, from the secondary memory to the main memory, and that page, if it is not available in the main memory and CPU is not able to process it, then in that case it will try to pop up the page fault indications. So basically this page fault, whenever it occurs, that need to handle in such a way that it is able to recover the page fault back to the main memory, so that the systems can able to execute the process in an appropriate manner. Now here, if you try to look across the page fault handling steps, there are some blocks is being shown over here. This is a logical memory, that is your secondary memory, and this is a page table related to the logical memory, and this particular is nothing but is your disk, and that is your secondary memory disk, and from there this particular file has to be transferred to the need to be transferred to the physical memory. So that's why the frame is being shown over here, and this frame is being compared with respect to this page table to find out is there any particular file available or not available, and based on that it will try to display the particular flag. Now here it is being shown that a required page is not in the physical memory is the page fault. So as I have already stated, if here a file which is needed in the physical memory, this is being requested based on the particular situations. That means suppose a program is running and the CPU needs that particular address content need to be brought from the secondary memory towards the main memory. So in that particular situations only it will call for that particular page demands. If the required page is not available, the invalid bit I will be shown in the page table. I is indicating in the flag I is indicating that the particular page is not available in the main memory. Page fault, it will be trapped by the operating systems. That means assume that a particular page is not there, so automatically the operating system will be trapping that particular fault, and thereby operating system will be trying to look for that particular page in the secondary memory. So the page on the backing store, whether that particular page is being stored, operating system will identify the page in the disk. So if that particular page is being identified, then it will identify the free frame in the physical memory. The page information will be activated in the physical memory and the frame number will be noted. That means once this particular page is being noted, you know that in the physical memory, one is frame number, another is frame size. So based on the frame size, the frame number is being identified, and that is being transferred to the page table, where the page number will be uploaded in the page table for the exact execution. Then a particular instruction will be restored that so automatically once this page table gets the that particular frame number, automatically it will try to load that particular page back, and thereby this particular the data is coming here, and the same process is repeated, and the page is being transferred back to the physical memory. So the logical memory will try to load that particular memory back to this particular. So this is the page fault. That means if anything is missing, flag is activating, operating systems will be getting a trap signals, and it will be identifying from the disk, transfer to the before transferring it will identify the particular frame number that is being given to the page table. Then page table will be retrieving that data back, and then by it will restore back to the physical memory. So this is the page fault. Now page fault, if the page fault is let's see one example. If the page fault is not available in the main RAM, is called page fault. So these are the logical memory, these are the physical memory. So if a particular page is not available, so this base corresponding to that page, a frame is being identified, then the frame number is being located, and the second and then the disk is transferring that particular page to page fault. Page size is equal to frame size. I have already, so size will be same, that's one, because just like in the page, this is one page, so here this is a page number 1. So but content if I am transferring this one into some other format, say I want to convert this one into PNG, content will be same, transferring. Only the thing is that it is a one page, it will be there, only that this content I cannot able to, with the format it will be change in one format to another format, the size of the memory will be reducing, but the content remains same. Process executions needed a logical memory space. Logical memory space and physical memory space is divided into page and frame. Pages needed to there is the frame. That means number of pages and the number of frames, it may be varying, but the size or the offset we keep it same. Page table will have a mapping from the logical memory to physical memory. Page number is equal to, page number is mapping to the frame number. If the page is found in the frame, then it is called as hit, and if the particular page is not there, then it is called as fault. So hit is there and the fault is there. So the page fault occurs when the program attempts to access the block of memory that is not stored in the physical memory or RAM. The fault notifies is the operating system that is not located in the data in the virtual memory, that is RAM, so from the secondary memory, then transfer it back from the stored hard disk to the RAM, that is your main memory. So this is what we discuss about page fault and how it has to handle.